In section 4.4, we're going to take a look at factoring. I know you've done a lot of factoring in Algebra 1 and in geometry, but we're going to take a look at factoring. This should be a review lesson, but please do take the time to review to make sure that you understand how to factor, because factoring is going to come up a lot in Algebra 2. So this first example that we have is x squared plus 9x plus 20. So how will we factor? We take a look at our a times our c. So our a is just 1. Our c is 20, so we go ahead and multiply those. So 1 times 20, we get 20. We're going to write all the combinations that multiply to 20. So when I do that, I have 1 and 20, 2 and 10, and 4 and 5. I need to see what combination multiplies to 20, but then adds up to this middle number, 9. So 1 and 20 doesn't work, 2 and 10 doesn't work, but 4 and 5, if both of those were positive, they would multiply to 20, but they would add up to 9. So then that's going to be my combination that I throw in there. And then that would be my final answer. Now, if I distribute this out, so distribute this x, distribute this 4, and combine my like terms, I'm going to get what I originally started with. Let's try another example. So I have x squared plus 14x minus 72. So take our a times our c, so negative 72. I write down all those combinations that multiply to negative 72, and I can stop once I see a combination that works. So then it needs to multiply to negative 72, so I'm going to have one positive, one negative, and add up to 14. So I go through my combinations, and I notice this last one that I have, that if my 18 is positive, my 4 is negative, it adds up to 14, but it multiplies to negative 72. So that's my combination that I'm going to throw in. Now, if I would have put x plus 18 and then x minus 4, that's still going to be correct. Just make sure that my 18 has to be positive and my 4 has to be negative. Now in this next example, notice how my x squared is negative. That's going to make it a little bit more difficult. So to make it like 1 and 2, I'm just going to factor out a negative 1. So if I factor out a negative 1, that switches all of these signs to the opposite. So now my x squared is positive, this is negative, and then this is positive. Now I can just continue to factor what's in parentheses further. So I take my 1 times my 12, I get 12. I need to write down the combinations that multiply to 12, so 1 and 12, 2 and 6, and 3 and 4. But what multiplies to 12 but adds up to negative 13. So it would be negative 1 and negative 12 would be my combination that works, that it multiplies to 12, it adds up to negative 13, so then I throw that in. Make sure you don't forget about this negative 1 that we factored out. That still needs to be in my final answer. So this next one, notice instead of 3 terms, there's just 2 terms. So for this one, whenever there's 2 terms, look to see if it has a greatest common factor. So what goes into 6n squared and 9n? You'll notice a 3n goes into both of those. So I'm going to bring out my 3n, divide both of these by 3n, and see what's left over. So if I take 6n squared divided by 3n, I have 2n left over. 3n or 9n divided by 3n is then 3. Now if I distribute this, I should get what I originally started with. So it's kind of like you're going the reverse order of the distributive property. So let's try another one of those. Now this problem, I have 3 terms, but what is the greatest common factor? What goes into all 3 of those? And you'll notice a 4 goes into all of those, so that I can divide all of those by 4. So I want to go ahead and do that. That if I divide each of these by 4, I bring that out, then what I have left over is x squared plus 5x minus 14. Then from here, since I have 3 terms left over, I want to see if that factors further. So take my 1 times my negative 14, I get negative 14. What multiplies to negative 14 but adds up to 5? So I have 1 and 14, 2 and 7. So I'm going to use that 2 and 7. My 7 would be positive, my 2 would be negative. I throw that in, and then I leave that 4 on the outside, and that's going to be my final answer. This next one, it's back to having just 2 terms, so look to see, does it have a greatest common factor? What goes into both of those terms? I notice the 7 does, so I'm going to factor out that 7. I have n squared minus 3 left over. The n squared minus 3 does not factor any further, so that would be my final answer. Now, this next one, if I take a look at it, notice how it doesn't have a greatest common factor. Something doesn't go into all three of those terms, so I can't factor out the greatest common factor. And this A is not 1. So this one we're going to do factoring by grouping. So let's take a look at this one. I still take my A times my C. So 2 times my 12, I get 24. I write all the different combinations that multiply to 24, and then I had to see which one adds up to 11. So you'll notice that 3 and 8, if they're both positive, they multiply to 24, but they add up to 11. Now I can't just throw that in like I did on these top examples because this A is not 1. So instead, what I'm going to do, replace this 3 and this 8 with my middle terms. So I leave the first term, leave my last term, but instead of 11x, I'm going to put in 3x and 8x. That still adds up to equal 11x. So I'm not changing the value of the problem, I'm just rewriting it. But then from here, now I have 4 terms that I do my grouping. Group the first 2, group the last 2. And I want to see what goes into both of these first 2 terms. So an x does. So I factor out an x, and then I have 2x plus 3 left over. These next 2 terms, a 4 goes into both of those, so I factor out a 4, and then I write what's left over. So 2x plus 3. Now from here, how I can check if I'm on the right track, what's in parentheses should be the same, which it is, so that's good. So that's going to be my one set of parentheses, 2x plus 3, and then what's on the outside, my x plus 4, that's going to be my other set of parentheses. And notice the order of these parentheses does not matter. So I could have it 2x plus 3 times x plus 4. Now let's try another one by grouping, because normally factoring by grouping is the type of examples that I have the most questions on. So this next one, I have 4x squared minus 4x minus 3. It doesn't have a greatest common factor. Nothing goes into all 3 of those terms. I want to do that first if I can do that. But it doesn't work for this one. So I take my A times my C, I get negative 12. Write all the combinations that multiply to 12. So 1 and 12, 2 and 6, 3 and 4. Has to multiply to equal the negative numbers. I'm going to have 1 positive and 1 negative. And it has to add up to negative 4. So I'm going to have this 2 and 6. The 6 would be negative, the 2 would be positive, that adds up to negative 4 and multiplies to negative 12. So I can't just plug that in as my last terms. Instead, I'm going to replace it with my middle 2. So I'm going to have positive 2x and a negative 6x. It doesn't matter the order in which you place those in there. Either way would work. Just make sure the 6 is negative and the 2 is positive. And that still adds up to equal negative 4, so I can replace it. I'm not changing the value of the problem. And then I'm going to do grouping. So group the first 2, group the last 2. And what goes into the first 2 terms is 2x, so I factor that out. And then I divide both of these by 2x, and I have 2x plus 1 left over. And if I distribute that, I get what I originally started with. Out of these 2 terms, a negative 3 comes out. So then if I divide both of these by negative 3, I have 2x plus 1 left over. Notice what's in parentheses is the same, so that's good. So I have 2x plus 1 is my one set of parentheses, and then what's on the outside, this 2x minus 3, is my other side. Let's try another one. So I have 4x squared plus 7x plus 3. So again, it doesn't have a greatest common factor. So I take my 4 times my 3, I get 12. Write all my combinations down. Has to multiply to 12, but add up to 7. So this last combination works if they're both positive. And then from here, I replace that with my middle term. So 7x, I'm going to instead have 4x plus 3x. And then do my grouping. So what goes into both of these terms is 4x, and then I have x plus 1 left over. What goes into both of these terms is 3. What I have left over is x plus 1. And then inside parentheses is the same, so that is good. So I have x plus 1 for my first set of parentheses and 4x plus 3 in my other set of parentheses. Now, these last couple of examples are going to be special cases. And how I know that they're special cases is my first term and my last term on them are going to be perfect squares. So what I mean by a perfect square is square root of 4 is 2, or square root of 36 is 6 as a perfect number. Okay, so anytime that we see that the first and last term are perfect squares, I'm going to automatically make my 2 sets of parentheses. Take the square root of this first term, so square root of 4x squared is 2x, so that's my first terms. Square root of 36 is 6, so that's my last term. And then my middle term is negative, so both signs are negative. If that middle term is positive, both signs would be positive. So then I have 2x minus 6 times 2x minus 6. Since they're the same, I could just rewrite it as 2x minus 6 squared. Or I can leave it as this answer right here. I will take either answer. Now this next one, again, those are perfect squares. If I take the square root of 64x squared, I get 8x, so that's going to be my first term. Square root of 1 is 1, so that's my last terms. Middle term is negative, so they're both negative. I can leave this as my final answer, or I can rewrite it as 8x minus 1 squared. Now this next example, notice the first and last terms are perfect squares, but it has no middle term. So I'm going to do the exact same process. Square root of the first term is 5x, square root of my last term is 7, but to get no middle term, or for the middle term to cancel out, I'm going to have one of each, one positive, one negative. And my final example, 6x squared minus 81. Again, it's a perfect square. So square root of the first term is 4x, square root of the last term is 9. No middle term, so I have opposite signs, one positive and one negative. And that would be my final answer.